This week we're going to talk about factoring strategies. We have several different types, and each type of factoring will be a different video. So we're going to start by talking about greatest common factors. So when we think about what a greatest common factor is, it's going to be the largest factor that divides into both numbers or however many numbers you have. So for this example, we are looking at the greatest common factor of 18 and 24. So if I think about the number 18, the factors for 18 are the numbers that multiply together to give me 18. Okay, and when we do this, we're thinking whole numbers. So we don't care about fraction values, decimal values, we want whole numbers. So every number is divisible by 1, okay, in itself. So 1 times 18 would give me 18. Okay, and then I can just go down my list of numbers. So the number after 1 is 2. So I can say to myself, okay, does 2 divide into 18? And it does. It gives me 9. Same thing, I'm going to look at the number 3. Does that divide cleanly into 18? It does. It gives me 6. Okay, then I think, okay, after 3 I get 4. If I do 18 in my calculator, I can do 18 divided by 4. This does not equal a whole number, so it does not go on my list of factors. Same thing with 18 divided by 5. Okay, it does not give me a whole number. And I know then that I'm done with my list of factors because the number after 5 is 6, and 6 is on my list of factors already. So there's no other possible values, no other possible numbers that can divide into 18. So then if I look at 24, okay, again, you can always start with 1 times the number as your first set of factors. This is an even number. Even numbers are always divisible by 2, and 2 times 12 would give us 24. Okay, 3 times 8 gives us 24. And 4 times, oh, not 5, my bad. 4 times 6 gives us 24. And the only number between 4 and 6 is 5. Okay, 5 is not go into 24, so it doesn't go on our list. And because I don't have any more numbers between 4 and 6, I know that I'm out of possible factors. Okay, I don't have any more. So now the problem is asking me to look at the common factors. So that's the list of factors for each number, okay? But now I want the common factors, okay? So that's all the numbers that are in common on my list. So both have 1s, okay? Both have 2s. Both have a 3 as a factor, okay? Both have a 6 as a factor. 9, no. 18, no. None of those others, no. So my common factors are 1, 2, 3, and 6. Okay. The last step, which of those common is the largest? Okay, so if I look at that list, 6 is my largest. So the GCF, okay, of 18 and 24 is 6. Okay. Because that is the largest number, okay, that divides cleanly into 18 and 24. All right. So this process is something that as you kind of get used to it and you first start to do it, you can write out the steps for it. But this is something that you can transition to doing in your head. Okay. So know that the work for this, if you want to show it, and then maybe once you've shown it a few times, you're like, okay, I've got it now, you can start doing it in your head from there. Or maybe you can jump straight to doing it in your head. Kind of up to you how much work you want to show in your own homework. Okay, let's try a problem now that has variables where we look at the different factors, okay, of x cubed and x to the 5th. So if I think about x cubed, okay, anything times 1 is a set of factors, okay? The other set we could think about as x to the first times x to the second is one way this can be broken down, okay? Because remember here we would add our exponents together, so the 1 plus 2 gives me that exponent of 3. Okay. And I don't have anything else, any other way I could break this down, because notice I go 1, 2, 3 in my exponent spot. There's no other possible ways x cubed could be broken into pieces. Okay, so if I think about x to the 5th, okay, I have 1 times x to the 5th. Then I have x to the 1st times x to the 4th, because 1 plus 4 equals 5. And then I have x squared times x third, because 2 times 3 would give me 5. Okay. And that is my list of factors, okay, for x to the 5th. So now if I think about my common factors, okay, it's everything that these two lists have in common. So they have in common a 1, an x to the 1st, oops, sorry guys, my iPad got weird, an x squared, and an x cubed. So if I write my list, those are the list of common factors. Okay, so common. If I think about greatest, which factor is largest, it's going to be this x cubed. Okay, so the greatest common factor of x cubed and x to the 5th is x cubed. Now, I want you to think for a second, why is that x to the cubed special? So if you notice, x cubed, which is our greatest common factor, is one of the terms that we started with that we were looking at. Okay, and it was the term that had the smaller exponent. So if we look at these two exponents, 3 is less than 5, okay? So that means that this is going to be that greatest common factor every single time, okay? And that will be true anytime we have variables raised to exponents. If you look at your list of variables, you look for the smallest exponent, and that's going to be the GCF, okay? So let's try this in practice now. So we have some expressions, and these expressions have variables and numbers. Okay, so we're going to kind of combine what we learned in those past two slides into these problems. So if we look at number 1, I'm looking for the number, okay, that divides into 20 and 30, and I want the greatest number. So if I think about values that go into 20, okay, so again, you can list this out if you'd like. So the numbers that go into 20 are 1 and 20, 2 and 10, and then 4 and 5. For my number 30, I've got 1 times 30, 2 times 15, 3 times 10, and then 5 times 6. Okay. Now, if I look at my list, I have some things in common. Okay, both have a 1 and a 2. All right. Both have a 5, but those aren't the greatest. The greatest number that goes into both is going to be that 10. Okay, so I can pull a 10 out. Now, the next step is looking at my x's. Okay, so my smallest x is going to just be an x. Okay, because if I think about my exponent here, it's going to be x to the 1st. Okay, so I'm going to pull out an x to the 1st. And then what I leave behind, okay, notice what times 10 gave me 20. Okay, I have it right here. All right, so that's what gets left behind here. When I pull a 10 out, I leave behind a 2. Okay, I'm gonna pull 1x out. Okay. So if I pull 1x out, that leaves behind a single x. Same idea over here. I can look right here to tell me what gets left behind. So 3 times 10 gave me 30. So I'm going to leave behind a positive 3. And my x got pulled out. Okay, so I can close my parentheses. You can always, always, always check your work. So you can check by distributing. Distribute. Oh, I spelled distributing wrong. There you go. So you can always check your work by distributing. So if you do the 10x distributed into both of these terms, you should get your original problem. Okay, and that'll work every single time. So you can always check your work for these problems. Okay. So that is example number 1. Let's look at example number 2. So if we look at example number 2, okay, I'm going to show you guys kind of a shortcut. Okay, to instead of writing out the list of factors, something you could do is you could say, okay, what is my smallest number? I have a negative 16, a positive 8, and a negative 4. So if I think about which one is smallest, I have a negative 4. And then just test it. See if it happens. Does negative 4, does that divide into 16? Yeah. Does that divide into 8? Yeah. So my GCF here, I'm going to pull a negative 4 out. Okay. And what gets left behind if I pull a negative 4 out from here? Okay. Negative 4 times what would give me a negative 16? It would be a positive 4. If I look here, a negative 4 times a what would give me a positive 8. So notice this is a positive in front of that 8. So the only way to get a positive when I have at least one negative is to have 2 negatives. So it's got to be a second negative. And then if I think about my numbers, 4 times 2, so negative 4 times negative 2 would give me that positive 8. And then here I'm pulling out the negative 4, and that'll leave behind a 1. So negative 4 times 1 gives me negative 4. So that's how each of those breaks down. If I think about my smallest x, okay, what is my smallest x exponent? It's going to be a 2. So my x squared is my smallest x. And then if I think about my smallest y, I look at each of my exponents, I see that I have a y cubed. Okay. And that's what I'm going to pull out from each of these terms. Okay. And so when I do that, and I'm going to move this down so I have a little bit of space. Okay. Again, this is stuff you can practice writing out initially, or you could do it in your head as you work through the problem. Here, if I think about this whole term, okay, if I'm pulling an x squared out, okay, what gets left behind here? 4 minus 2 would give me 2. Okay, and then in terms of my y's, I have y. I still need a little bit more space. I have y cubed being pulled out. So if I do 5 minus 3, okay, because that's what I'm pulling out, I'm going to be left with y squared. So my greatest common factor that I'm pulling out, okay, is I'm going to pull out the x squared, and then I'm going to pull out the y cubed. So this is what gets left behind. So I can go ahead and write that out. So this is also what's getting pulled out. Negative 4, okay. X squared gets pulled out, y cubed gets pulled out. And then what gets left behind is going to be a 4 x squared y squared. And then I can go to my next term, okay, and think through that one fully. So if I think about x cubed, okay, if I break that down, if I pull an x squared out, 3 minus 2 gives me x to the first, okay. Y to the fourth, if I pull out a y cubed, all right, 4 minus 3 gives me 1. So I'm left with y squared. So again, these are those GCF values that are getting pulled out. Okay. And then this is what gets left behind. So I can write this as negative 2xy. Okay, so I don't have to write the x to the first, y to the first. I could just write xy. Now, for this one, okay, I'm pulling out an x squared, and that'll leave behind that imaginary 1. Okay. And then I'm pulling out a y cubed, and that's also leaving behind an imaginary 1. So for this term, I'm actually pulling out the GCF fully. Okay, that term is my GCF that I'm pulling out. So the only thing that's getting left behind is 1 times 1 times 1, okay, which is just going to give me a positive 1. So that is number 2. So that one had a little bit more going on, okay. So again, you do not have to write out all that kind of scratch work, but I know for some of you, the first few times you do it, it's helpful just to kind of visualize what's happening here. So my final answer is this. Okay, let's look at 2 more examples. Okay, so I want you to take a second and I want you to think about the answer for number 3. Okay. So for this one, hopefully that you notice that here, okay, 15 could be divided into 3 times 5. And here we could divide this into negative 5 times 5. Our smallest x, so our smallest x exponent is x cubed. Our smallest y is y squared. So in terms of our GCF, okay, it's going to be 5 x cubed y squared. Okay, so if I write it out, I get 5 x cubed y squared, and then what gets left behind here is a 3, okay, and then nothing in terms of my exponents. Okay, what gets left behind in that second term is a negative 5. Okay, and I'm gonna have 1x and 1, oops, I almost wrote another x, 1y that gets left behind, and that is gonna be my final answer for this one. And again, you can always multiply that in to double check. Okay, I want you to try number 4. Okay, so for this one, hopefully you found a GCF of negative 2x. Okay. So our smallest x was x, and if I pull out that negative 2x, what gets left behind here, okay, would be an x squared. What gets left behind here would be a negative 5. So a negative 2 times a negative 5 gives me that positive 10. And I'm taking 1x away, so that leaves 1 behind. Okay. And then lastly, if I pull a negative 2x out from here, that's going to leave behind a positive 3. And that's going to be my final answer for this one. Okay. One thing I didn't mention is that when you have a negative leading term, so when we say leading term, that means it's the first term. Okay. Anytime you have a negative leading term, you're going to factor the negative out every single time. Okay. Even if this 2 wasn't right here, so say that 2 wasn't there, you would still need to factor out a negative. Okay. So anytime you have a negative leading term, factor out a negative. Okay. That's just kind of a rule of thumb. So that is the end of this video. Let me know if you have any questions.